And we're still at it, and we're on question 7. So let's go into it. And we've got these functions, and the functions, there's so many function type questions that come up, and you'll see it's the same concepts that come up. So once you start getting into functions, you get into them a bit more and they start making a bit more sense. So we've got two functions here, f and h. Been kind enough to label them for us, but they didn't have to, because if we looked at f, we went, oh, what type of function is f? Well, it must be a parabola. Look at that x squared sitting there. Is it a happy or a sad parabola? Well, I kind of don't like this idea almost. I keep on saying happy, sad, and then thinking, what makes this one sad? Well, it's just what we use, right? And what type of function is h of x? Well, it looks like a straight line to me, so there's our straight line. As I said in the previous video, if you watched it, you'll know, well, it can be useful to highlight these. If you've got it in front of you, it just makes them stick out and zing a bit and go, ah, look at that. For me, there's a visual link already. And functions, we're drawing them. They're inherently visual in the way we're tackling them. They intersect at A and E, so we're just checking that everything we've been told, there's A, and at E, I think it's useful to go, well, something we know about A already is that its y value is 0. While we're at it, something we know about B is that its y value is 0. What are points A and B on the parabola? Like the x-intercepts. How would you find the x-intercepts of the parabola? Well, how do you find the x-intercepts of any function? You just make y equals 0. So we know that we can find these. So let's finish looking through what they've told us, because I don't think there's much else that's too interesting, and see if we know we can find all of these points, because then we can tackle any question that comes our way. So let's keep going. We've got point C. What do we know about point C in terms of its values of x and y? We know its x value is 0. How do we find the y-intercept of any function? Well, just make x 0. So this bit, I'm going to put a dot because we know we can find it. We can find these two. D is the turning point. So it's this turning point here. How do we find the turning point of the parabola? Well, the way we've done it is we said we don't have this in turning point form, otherwise that would have been really beautiful and easy, right? So what we're going to do is we're going to find P and Q. So remember, this was the idea of going, this is PQ. How do we find P? What little shortcut did we use for it? Well, we said minus B over 2A. How did we find Q? Well, two different ways. One way we generally looked at was to say, let's just substitute whatever this value is to find that. It fits in. How do you find the output? Well, you substitute in the input. So if you're given the x value, you can find the y value. Otherwise, one or two of you are using the formula, and I'm not going to write that down because not all of us have used that. But if you use the formula to do it with A, B, and C, that's perfectly fine as well. So we can find P and Q. And point E, how do we find out when two graphs are equal to each other? How do we find out when they intersect? Maybe more difficult, and we'd use simultaneous equations. You can just go, that graph equals that graph. I mean, really, simultaneous equations, we're going to say, when does that graph equal this graph? We've got an equation for this, we've got an equation for this, so therefore we can find out what E is. So far there are lots of things we can find, and one of those points where they intersect is going to turn out to be A as well. So that'll help us in our factorization when we get to that question. Doesn't look like this point is too interesting. It wasn't even labeled, but if we did want to find it, we know that the x value is 0, and in fact it's 2. Maybe that's why it's so boring. Look, 2, just read it off. Cool. So we can find all the points given. Determine the length of AB. Easy, right? How do we find the length of AB? Well, we're going to find that coordinate, and we're going to find that coordinate, and then you're just going to find the difference. So let's say like that's -2 and that's 4. Well, then that whole length is 6, for argument's sake. Determine the length of OC. Well, we know that we can find C easily. We've gone through how to do that. So if that were sitting at like, yes, I'm looking here, if it was sitting at like 0, 8, then we know that distance is 8. And really, 1 mark, because look what happens when you substitute 0 in here. Goodbye, goodbye, you're just left with 8. So it's like really a gimme to go, well, you can almost fill that in and fill it in on your diagram because you can use it. So whatever you find out, fill in the diagram, you can use it in any question, and we're going to look at your diagram very much as well. Determine the coordinates of D, the turning point of f of x. D, we've already talked through how we're going to do that. Easy. Oh, this is gifts once we know. Determine the coordinates of E. E, well, how do we find out when two graphs, and we did that, right? So we're going to make them equal to each other, simultaneous equation, get two values of x. One of them is clearly going to be for A, because it's going to be a negative, and the other one's going to be E, and then don't forget to sub in to find the y. Remember, for all of these ones, I always like to go, okay, finish off with it in coordinate form. It does ask for coordinates, so finish it off in coordinate form. Even here, determine the length of AB. It's nice to go, A is this, B is this, then they're sticking out at you, fill them in the diagram. Determine the length of OC. Well, we're going to find out what C is. Then at any stage you can scan and go, maybe I need A. Well, there it is, there it is. I know that I'm going to find out D. So as you scan through and get to the more complicated questions, you go, okay, now these last two, this is where we should be spending our time. Write down the values of x for which f of x is greater than h of x. So for these two things here, let's grab that and see if we can do this. Cool. So that's what we're looking at. That's useful. So we're seeing, when does f of x, when's our parabola and pink graph, when is it greater than or equal to h of x? What does that mean? Interesting ways of thinking what that means, and they're different, slightly different interpretations. I like to think, when is h of x, so f of x, so when is this graph greater than or equal to, so it must be above h of x or equal to, so we're including this bit in the middle. So we're saying, when does this happen? When is the pink graph above the yellow graph or equal to it? That's kind of maybe another visual way of looking at that. So we look along the x-axis and go, going from left to right, well, from that point, at this point, the yellow graph is above the pink graph. The straight line is above the parabola. Then between these 2 points, look, the pink graph, the parabola, is above the yellowy gold straight line. So this case, this is true. So this must be interesting, and from this part it's not interesting anymore. So you might say, it's between A and E for the x values. Now you've been filling in your diagram, so these things aren't sitting blank. So you're just going, I can just read these off the graph. That's the nice thing. Okay, then the next bit, and let's see what the question's asking, because these can get asked in various ways, this type of multiplying and dividing and that. So our next question, when you multiply these two functions, like what an interesting concept. When you multiply these two functions, when will the answer always be less than 0? So if you're multiplying this by this graph, it's going to be less than 0. So we're not saying when is the whole graph less than 0. Now when you multiply two numbers and their answer is negative, what do you know about the signs of these numbers? As in like signs being like the positive negatives. Well, either you're going to have a positive times a negative, because a positive times a negative is negative. Remember, this solution we want is negative. Or we're going to want a negative times a positive. This function's good now, right? So I'm not covering, or maybe I wasn't covering it up anyway. But we've got a positive, so we're looking at one of these scenarios. Scenario 1 or scenario 2. So let's start by looking at option 1. When is the pink, the parabola, positive and the straight line negative at the same time? Well, as we're looking, let's take a slice somewhere. Let's look at this point here. Well, at this x value, the straight line's negative and the parabola is negative. So therefore this isn't true. What about over here, like at 0? If we look straight up, well, both of them are positive, right? Both of them are above the x-axis. So that's not the case. So that's what we're trying to look at. Or keep going along. At what stage are they? Is the one positive and the other negative? So you kind of actually, I think, it's useful looking at both of these. And when is one positive and the other one negative? So you go both negative, both positive. I mean, even at E, look, they're both positive. Remember, we're looking at the Y values, the outputs. And maybe at this stage, hey, look, like here, this X value. Well, that's positive, and this thing's way down here somewhere and is negative. So that's the idea behind that question. It could be asked in a number of ways. Could it be an f of x over h of x? When's that negative? Well, it's the same idea because a positive over a negative. Or when is f of x? Yeah, so those are the ideas behind those questions. Spend a bit more time on them now in this video, as if, well, these 4 marks might take you longer. They may well. Remember, it's not kind of, mark a minute, so if this takes you longer than 2 minutes, this is a bit more in-depth in its thinking for these 2 questions, but there's the idea behind it, and there may be some visual ways of thinking of them. Okay, that's that.